Hi, this is NachoMath, and in this video I'll be showing you how to remember the unit circle easily. First you have to draw the circle, which I've already done to save time in this video, and then you fill it up with the lines that you typically find on the circle. They usually have one vertical, one horizontal, and a bunch of diagonal lines. There should be 3 lines in each quadrant. Then you've labeled the circle in radians from 0 to 2 pi. If you would like degrees as well, you can write that in as well, but I'm just going to do radians for now. Then you start by labeling the easy ones. For example, the coordinates at 0, pi over 2, pi, and 3 pi over 2 are either like 1, 0, or 0, 1, or any like combination of negatives and positives. Because a unit circle is just a circle with a radius of 1, so you could treat it as any other coordinate plane. So this would just be 1, 0. This would just be 0, 1. This would be negative 1, 0. Don't ignore the fraction bar. I forgot about that one. And this would be 0, negative 1. And now you really only have to remember the points, the coordinates in the first quadrant, because all the other ones we can build off of that. How I remember it is the denominator is always 2, so I fill that in first. And then it goes, starting from the bottom, it goes 3, 2, 1. And then once you get to the top, you start again, going back down this time, 3, 2, 1. So when you start from the bottom, you go, you count backwards, 3, 2, 1. Once you get to the top, the y coordinate, you start from the top this time, and you count down 3, 2, 1. They all have radicals on them, like all the numerators have a square root sign, but so this would be the square root of 3, this would be the square root of 2, the square root of 1 is 1, so I can leave that, and then the square root of 3 is 3, the square root of 2 is 2, and again the square root of 1 is just 1, so you leave that. Now, why do you only need the first quadrant to find out all the other ones? Well, the unit circle is actually symmetrical both across the y-axis and the x-axis. So you can just copy, like if you make sure that they're symmetrical on both sides, you can just copy it on the other side. So I'll just do that right now. Again, I'm just copying everything from the right side to the left side. And then, since the bottom is also symmetrical to the top, you can just fill in the bottom symmetrically as you would the top. So this coordinates with this point, so this is radical 3, radical 2, 1/2. Pardon me, I already wrote the fraction signs in, I forgot. And this coordinates with this point, so, oh man, I keep doing that. Alright, so as you can see now, everything on the right side of the circle is symmetrical to everything on the left side of the circle, and everything on the top side of the circle is symmetrical to the bottom side of the circle. Now, the only difference between these 4 quadrants are the signs of the x and the y values. In the first quadrant, both the x and the y values are positive because you're going right and up. Now, on the second quadrant, the x value is actually negative because you're going to the left the y value is still positive because you're still going up, but it's to the left and up. So you just have to add a negative sign in front of all the x values. So as opposed, like, let's say cosine, which is the x value, cosine of pi over 3 is 1/2. The cosine of 2 pi over 3 would be negative 1/2 because it goes to the left. In the third quadrant, it's going to the left and down. So both the x and the y values are they're both negative. So just put the negative signs in front of those. In the fourth quadrant, the x values are positive, but the y values are negative because it's going to the right and down. So put a negative sign in front of the y values. If you're wondering where these numbers come from, I'll make a video about that later, but for now, just remember these numbers. So again, this is why you only have to really remember the first quadrant, because all the other quadrants can be built off it, and you just have to add in the negative signs where needed. To memorize this, just write this circle like 3 or 4 times. Just copy it down from memory instead of from memory, and then soon you'll memorize it. What you can also do is just ask yourself in your head, after you've copied it down a couple times, just ask yourself in your head, like, what is the sine of 5 pi over 6? And then try to imagine where 5 pi on the 5 pi over 6 on the circle is, over here. Picture it in your head, and then try to see that it's 1/2. Another thing you could, another tip I do is, if I'm trying to find out what is the cosine of pi over 3, I think in my head, okay, pi over 3 is the one going up here, so the y value is bigger than the x value. And the y value, and it's not one of the perfect diagonals like pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. So since the y value is bigger, the only y value that I could use is radical 3 over 2. That's how I remember it anyways. And then some tips on the test. It's not necessarily good to copy this down before a test, or once the test is handed out. It's not always good to draw the full circle, because it actually takes quite a while to draw. By the time you take your test, hopefully you'll have worked with the circle long enough that you'll remember and you can get the answers from memory. So, because sometimes on the test takes the full 45 minutes or 90 minutes or however long your class is, and copying this down takes a few minutes, and that could be the few minutes that you could use to finish your last problem. So again, just memorize it instead. It's usually not worth it to copy this whole circle down before a test. Alright, thank you. Remember to like, comment, and subscribe if you want to. I'll be putting more videos up later. Bye.